Hi guys, last one for 8.2 here. So improper integrals, we looked at the ones last time when the bounds went to infinity. This time we can have discontinuities within the actual boundary area. So like there's maybe a vertical asymptote somewhere inside of where we're integrating from. All right, so when that happens, what we want to do is we want to split it up into multiple parts. So identify the infinite discontinuity, rewrite as a one-sided limit, integrate, and then take the one-sided limit at the end. So we still have to rewrite it as a limit. So what we have to do first is we have to figure out where's the problem area here. So for this guy, he's a fraction, x on the bottom. So 0 on the bottom is the problem area. So we would rewrite this as the limit as b goes to 0, and we're going from 0 to 1. So maybe to the right of 0, just a little bit bigger than 0, of the integral from b to 1 of, let's say, x to the negative 1/3. It's going to be easier. Said third. There we go. Dx. So if we integrate that, that's going to be x to the 2/3 over 2/3, or times 3/2 from b to 1. So we plug in 1, we're going to get, let's see, limit as b goes to 0 from the right. Plug in 1, we're going to get 3/2 minus, plug in b, we're going to get 3b to the 2/3 over 2, like that. And we can plug in 0 here. That's not a problem. So if we plug in 0, this is just 0. So we end up just getting 3/2. So even though we had an asymptote at one of the ends, it wasn't that bad. Or we had an asymptote at one of the ends. It wasn't that bad. All right, let's try this one. So again, 0 is the problem area. That happens a lot. So we're going to rewrite this as the limit as b goes to 0. And we're going from 0 to 2, so we're a little bit bigger than 0. From b to 2 of x to the negative 3 dx. So this would be x to the negative 2 over negative 2 from b to 2. So we're going to get the limit as b goes to 0 from the right of, let's see, negative, now let's go ahead. Let's say this is 1 over negative 1 over 2x squared from b to 2. So if we plug in 2, we're going to get negative 1/8 minus negative 1 over 2b squared, like that. All right, so if we plug in 0 from the right, that's going to be a problem on the bottom there. So we're going to get negative 1/8 plus, and this 0 to the right, this is going to go towards positive infinity, right? We get 0 on the bottom, it's positive, the top's positive, we're going to positive infinity. So positive infinity minus 1/8 means we are going to positive infinity. So this diverges, and it goes to positive infinity. So this has an infinite area under it between 0 and 2 because of that vertical asymptote. This one was small enough that it didn't. All right, now we could also have a discontinuity somewhere in the middle. Like this guy has a discontinuity right at 0. So what we would have to do is we need to break this and say this is the limit as, say, b goes to 0 from the left, from negative 1 to b, of x to the negative 3 dx, plus the limit as, we need a different letter. So we'll say a goes to 0 from the right, of a to 2, of x to the negative 3 dx. All right, now if we integrate that, I don't think it's going to end well for us, but let's go ahead anyway. X to the negative 2 over negative 2, from negative 1 to b. Same thing here, from a to 2 though. And let's see, this is going to be, this is basically what we did last time. This is going to diverge because it diverged last time. So it's going to be negative 1 over 2x squared from negative 1 to b. If we plug in b here, we're going to get negative 1 over 2b squared minus negative 1 over negative 1 squared. So we get 2. So that's going to be plus 1/2. And this is going to be the limit as b goes to 0 from the left. So this is going to go to negative infinity. That's going to be a problem. Plus the limit as a goes to 0 from the right. Let's see, this would be negative 1 over 2x squared from a to 2. If we plug in 2, we're getting negative 1 over 8 minus, plug in a, it's going to be negative, so 1 over 2a squared. All right, so this one's going to negative infinity. This one's going to positive infinity. All right, so we're getting infinities at both of them, so they're both diverging. So it diverges. All right, and last one here. Use the formula for arc length to show that the circumference of the circle with a radius of 1 is just 2 pi. All right, well, if we're going to use the arc length formula, we probably need to solve for y. So y squared would be 1 minus x squared. And if we take the square root, this would be the top half of the circle. And what we can do is we can break the circle up into just this portion here. So this would be 0, this would be 1, and this would be 4 times that, so times 4. So we would have that the arc length, or the circumference, I guess would be what we're talking about here, is 4 times the integral from 0 to 1 of the square root of 1 plus the derivative of this squared. So we need the derivative. Y prime would be, so this is 1 minus x squared to the 1/2. So there'd be 1/2, 1 minus x squared to the negative 1/2 times the derivative of the inside, which is a negative 2x. The 1/2 and the negative 2 are going to cancel. And now we're squaring that. So we're going to get negative squared, that goes away, x squared, and this guy squared. So it's going to be 1 minus x squared to the negative 1. All right, now you're probably wondering, why is this in this section? Well, if we rewrite this, this is 1 plus x squared over 1 minus x squared dx integral. And 1 gives us a problem if we plug in 1, right? We can't have 1 at the bottom of this guy. So we'll go from 0 to b, and we'll say it's the limit as b goes to 1 from the left. So it's a little bit less than 1. All right, now we can try and take this actual integral. So if we want to take this, we can get a common denominator here. This would be 1 minus x squared over 1 minus x squared. These x squareds are going to cancel. And we are left with, on top, just 1. So the square root of 1 is 1. On the bottom, we've got the square root of 1 minus x squared. And we're going from 0 to b. And we still have the 4 out front. And we're still taking the limit as b goes to 1 from the left. All right, this should look familiar. All right, this is arc sine. So we get 4 times the arc sine of x from 0 to b. So we get 4 arc sine of b minus 4 arc sine of 0, which is 0. So that goes away. And we're taking the limit as b goes to 1 from the left. Well, the arc sine of 1 is just pi over 4. So we get 4 times, or not pi over 4, sorry, pi over 2. That's where sine equals 1, pi over 2. Sine looks like this, and this is pi over 2. 1. All right, so we just get 2 pi as our answer. And that's what we wanted to show, is that it was equal to 2 pi. There it is. Done. All right, so that's how we deal with discontinuities in the middle. We split it up, or if it's just at one of the endpoints, we can also still just rewrite it as a limit.